All right, so today's class is going to be a lesson review of last lesson because last lesson we worked on linear equations. All right, and those are like quite hard to solve when you're just learning it. So a lot of you just got introduced to these type of equations. So most people did decent on their homework, but there were some people that needed help and specifically asked for help. So I'm going to do a review lesson on this type of stuff. So any questions about like particular questions that I should go over? If there aren't any questions, then I will go to the schedule. So our schedule for today. First, we're going to, of course, go through some homework questions. And since the homework was pretty challenging, since of course, it's our first time working with these simple equations and we're solving for variables. So I'm going to go over all of the homework questions. So if you do have any questions about like a particular homework question, then I will go over all of them. All right, and second, we're going to review the inverse operations because I did notice somebody when they moved like a numeral or a variable to the other side, instead of reversing the sign, they just kept it, right? So maybe if x minus 4 is equal to 0, okay, then you need to move that 4 to the other side. Then you move it to the other side, it would become positive 4, right? And I saw some people, instead of moving it and turning into positive 4, you subtracted 4 from both sides, which would not cancel anything out. All right. So, and then we're going to review solving, of course, simple equations, and then some practice problems. And let me go over like lesson reviews. So a lesson review, we're going to have a couple of those. Basically, they're reviews over particularly challenging lessons. Hopefully, we won't have too much. Okay. So in particularly difficult units, we may have multiple lesson reviews. And of course, that one unit review at the very end. And a lesson review just consists of the main topics of the last lesson. So we're just reviewing the main topics like inverse operations, what's a linear equation, how to solve it. And of course, I'm not going to give you the same examples, the same practice problems. I'm going to switch it up a little bit. So all fresh, new practice problems, and we're just going to keep practicing this concept. All right. So are there any questions over our schedule and this lesson review? Any questions? All right. If there aren't any questions, then I will begin. So let's go over our first homework question. Most of you did pretty well on this. So just everybody just post your answers in the chat for this question, and then I'll go over it. All right, so I'll give you a few moments to post your answers in the chat, and then I'll show you how to solve this one. All right, so we have 3 answers right now. So we have negative 3.71 approximately, okay? And then we also have from William negative 26 over 7. All right, so negative 26 over 7, type that into your calculator, and then you do get negative 3.714. Okay, it's the same thing. But we also have negative 5, 35 over 7. Negative 35 over 7 would be equal to negative 5, though. Okay. All right. So is a mixed number, then it'd be 3 plus 5/7. Okay, so 3 plus 5/7, so negative 27, 26/7. Okay, so I think that everybody got about the same answer, which is very good. So today, since it's a review lesson for those who did not quite understand, and it's like just reinforcing your knowledge for those who do understand, okay, you guys are going to take the initiative this class because I'm not teaching any like new material. So if you could please take part and participate. Um, so everybody, if you can, unmute yourself, and then you guys are going to tell me what the first step is. All right. So this is all review. So
Add
what's our
3
first step?
Add 3.
to both sides.
Add 3 to both sides. Very good. Whoever that said that.
Yeah.
So why do we add 3 to both sides? Okay. What's
Because
This is a
because
minus
we want,
3.
we want to get the variable by itself, so we could start by adding 3 so it can cancel out.
Yes.
very good? All right. So we want the variable to be by itself. So we want our form to be u is equal to a numeral where so u is equal to a where a is a numeral. Okay. So we want that. So if we want to cancel this 3 out and move it to the other side, then what we need to do to cancel this negative 3 out is to plus 3, right? Because inverse operations, the negative and the add sign cancel out. But of course, since these two are equal to each other, actually, it's not good. I'm going to have to use blue. Okay. So if you want to cancel out this negative 3, you want to add 3. And since these this negative 7u minus 3 is equal to 23, then you have to do it to both sides to keep the equality the same, right? So I'm gonna add 3 to this side, you gotta add 3 to the other side. Okay. So then you add 3. So you get negative 7u is equal to 26. So then you have the variables and the numbers on different sides. But how do you get u by itself? Just 1 times u. What is that going to be? So does anybody know how we're going to get just u by itself without the negative 7? How are we going to do that? To cancel the negative 7 out. All right. How are we going to cancel the negative 7?
Divided by negative 7.
I think it's I think to divide everything by 7 or negative 7 and then divide 26 by negative 7. So basically move the negative 7 to the other side.
Very good. All right. This is what we're going to do. We're going to divide both sides by negative 7 because then they would cancel out on this side, right? Then we only have u on this side. But of course, if we're going to do it on this side, we're going to have to do it on the other side. So then our final answer would be this. U is equal to negative 26/7. Okay? Or you could do what? Like 3 and then 5.
0.71 or something like that. Oh, never mind.
Or you could do it like mixed fraction, something like this. But I prefer the improper fraction because we just use it that way. Okay, it's ideal. So when you get too higher at mathematics, you don't use mixed fractions anymore. Okay,
So
you
they
just
won't
use
they won't deduct points if you use.
No, it won't deduct anything because they're still equal, right? But improper is basically like simplifying. Like 23 is still equal. 23 is equal to 20 plus 3, right? They're equal. But 23 is like the improper fraction, and 20 plus 3 is like a mixed fraction. It's like more simplified. All right, it's ideal. So when you answer, don't turn it into a decimal because let me just go to my calculator real quick. So 26, negative 26 divided by 7 is going to be a pretty long decimal. Okay, it's like negative 3.714285, and it keeps going. So if you approximate that, and you're not going to see the end of it, right? If you approximate that, that's not an exact answer. So you want to leave it into fraction form where it is an exact answer. Okay, it's like approximating the square root of 2. The square root of 2 is approximately 1.4, but that's not exact. So just leave it into the square root of 2. It's like same thing. So just leave it into fraction form. So from now on, try not to use decimals to like show your answers unless we're specifically talking about decimals like money. Of course, money you can only like show in decimals like $3.45, right? 3.45. Okay. So, but in this case, just use fractions. And the key point here, or what was the key point? I forgot. What is the key point? Oh, I just talked about the key point. Never mind. Leave it improper. That was the key point here. Okay. Yeah. Teacher using a calculator. Yes, of course I use a calculator. I'm too lazy to use standard algebra. Plus it's more efficient. Like, can you imagine doing negative 27 divided by negative 26 divided by 7 using long division? That'd suck. Okay. All right. Our second homework question is x over 5/3. All right. Minus 6 over 7 is equal to negative 3 over 5. All right. This one is a bit tricky. Okay. So please take your time with this one. I'll give you a few moments to complete this problem and post your answers. Okay. And keep in mind what I said earlier. Okay. Leave it into improper fraction, or I don't even, yeah. And don't go into decimals, any of that stuff. Okay. It's not worth it. It won't be exact. All right. Let's continue. Let's see our answers. So most of you guys got 3/7. Isabella said negative 1/7, and then never mind. So 3/7. Okay, so most of you guys got 3/7. Very good. All right. So how are we going to solve this one? See, a lot of you guys in your homework, I saw you did something like this. Okay, so first of all, of course, what is this? What is this weird thing over here? We can't have a fraction and then another fraction. Okay, that's just weird.
Multiply
No,
by that.
we're not going to do that. So if we're dividing, a fraction is dividing by another fraction. If you're dividing by a fraction, basically multiplying by its reciprocal, right? So that's what we're going to do. So basically x times 3/5. So then we get 3x over 5 minus 6 over 7 is equal to negative 3/5. Okay, then you begin this painful process of moving this to the other side. Okay, so what you need to do, so what do I do here? I add 6/7, right? To both sides, of course. And of course, this cancels out. Then I'm left with this. I'm going to do this. Very ugly number right here. Okay, very painful to try to add these fractions, right? So this is not a very efficient method, right? So in this other side, I'm going to show you another more efficient method. But first, let's finish this. Okay, so what you need to do, you need to get the common denominator, right? So negative 3/5 multiplied by 7, get negative 21 over 35, plus, and then 6/7 multiplied by 5, 30 over 35 is equal to 9/35. Okay, then what you need to do is, what if you multiply both sides by 5/3? Okay, if you multiply both sides by 5/3, then these 5's cancel out and these 3's cancel out. Perfect, we get x by itself. But of course, we need to multiply by this way too. If you don't understand why we're multiplying by 5/3, first, if you multiply by 5, then that's what you would do first, right? If you didn't multiply by 5/3, you would multiply by 5 to get rid of the 5 denominator, and then you would divide by 3, right? So this is multiplying by 5/3 is doing it on one step, okay? So after we're done with all this ugly computation, you should get something like this. 45 times 3 times, okay, so 45 over 35 times 3. Okay, so what is 35 times 3? It's 105, right? It's equal to 45 over 105. Then what do you need to do? It says divide by 15. Okay, so then you get 3/7. So that's your answer.
I think you could have crossed out for 9/35 times 5/3. You can cross out 35 and 5 and turn 35 into a 7, and cross out 3 and 9 and turn the 9 into a 3.
Very good idea. I don't know why I did not do that. Cross cancel. I learned that in 6th grade. I should have used it. Okay. Very good.
Wait,
Whoever
like
has to
as in
buy-
multiplying the both sides by like 5/3 to like canceling it to cancel it out. Is that what you mean?
Which part?
At the beginning to like, since that fraction thing is like weird, you can just cancel it out by multiplying by 5/3.
True. You could. But if you multiply everything by 5/3, this has to be multiplied by 5/3 too. So how are you going to do with that? Okay, if you multiply this by 5/3, it's going to be a pretty ugly number, right? If you multiply by 5/3, and this will turn into -1, and this will turn into x. But then you get this ugly number. How are we going to deal with that? It's still going to be inconvenient. So this is how I'm going to solve it. Okay, it's a more efficient way. So after you go to this step, so can anybody tell me what is the least common multiple of 5 and 7?
35.
35, great. So what if we multiply both sides by 35? Multiplying by the least common multiple of 5 and 7. Okay, so if you multiply by 35 on everything, right? Distributive property, Okay, you multiply by both sides. You're gonna have to multiply 3x over 5 and then negative 6/7. So don't make sure you multiply every term by 35. So if you get this, then these two cancel out. All right. So you get minus 35 times 6/7. See, this is very efficient, right? This is very efficient. Okay. All right. So then what you get is you get 21x minus 30 is equal to 21. Then you get what 21x is equal to 51. Then x is equal to 21 over 51. Oh shoot, I did something wrong. What did I do wrong? Come on. That's it. Someone tell me my mistake because I knew I made one in computation. I should have just oh, there we go. That's my mistake. What an amateur mistake. Okay, so 21x is equal to 9. There, that's the answer. See, it's much more efficient, right? Because you're working with integers instead of fractions. Because look at all this ugly computation. It's not very ideal, right? So if you multiply it by the least common multiple, right, then you can cancel out. It can't be greatest common factor or something like that. It can't be a factor, okay, because then it still remain a fraction. So it has to be a number that's bigger than both of these denominators. And it has to be the least common multiple because the least common multiple is easiest to work with. Okay, you could do 70. It's still a multiple and it would still work, but it's just less work. I say so we multiply by the least common multiple, then we can cancel both of them out. We just have to multiply this one by 7 and multiply this one by 5. Okay, and of course this one by 7 too. So then you're working with integers. Okay, it's very easy and less prone to mistakes because this one, if you have more fractions in our first method where we're adding all of these fractions, you may make like mistakes or something, and that's not ideal. So does everybody understand how I do this? Are there any questions on how I do this, the least common multiple? If there are no questions, then I will continue. Okay. So let's move on to our third one. So negative 24 is equal to 6 times 10 plus z. Okay. So this one is quite easy, right? You remember how to do distributive property, right? So make sure you review the distributive property. Okay, so you just distribute the 6. So negative 24 is equal to 60 plus 6z, right? Because this knowledge is all cumulative. So make sure you review these lectures. Okay, so then you move the 60 to the side. What you need to do, subtract 60 on both sides, you get 6z is equal to 84, negative 84. So then it's as simple as that. Divide by 6. Z is equal to negative 14. Okay, I saw some people who got this correct, but still came up with a different solution than negative 14. All you need to do is you need to take your calculator and punch in the numbers, negative 84 divided by 6, all right? And on these, 84 divided by 6 is not not something that everybody knows, like straight off the bat, right? So 12 times 12, that's 144. Everybody knows that, right? But like 84 divided by 6, that makes you wonder a little bit, right? So if you're not sure, just use a calculator, okay? Doesn't hurt. But z is equal to negative 14, so just make sure you know how to do distributive property and you know how to use the calculator. You're fine. Pretty easy. Now we get into this, okay? So first step, obviously, would be to multiply these. Okay, multiply these. So 3 times negative 2r is negative 6r. Pretty easy, right? So next side, kind of confusing. How are we going to do this? Actually, since 30 is multiplying negative r minus 2 divided by 6, then we can actually cancel this out, right? So what we're going to get is we're going to get 5. We're going to get 5 times negative r minus 2 over 1, right? Because 30 divided by 6, okay? It's going to cancel out. Okay, you can cross cancel. All right. So because basically what we're doing here is going to be 30 over 6 times negative r minus 2 over 1, right? That's what it really is. So if you just turn this into 5 times negative r minus 2 over 1, then you get 5 times negative r minus 2. Okay? Pretty easy, right? So then you have this plus r, and then it's just distributive property from now on. Okay? All right? Again, negative 2r is equal to negative 10r is equal to 5. All right, basically what I just did was move the r's to the side. Pretty self-explanatory. And then
Wait,
you
I got 15 over 192.
50 over 192.
15 over 192.
15 over 192. All right, so how did you do this problem?
I made the dumbest mistake ever by multiplying by 6.
Yikes. Okay. Wait a second. If you multiply by 6, it still works, right? So hold on a second.
Yeah, but then the numbers got really confusing and I think I just messed up somewhere.
Yeah, because if you multiply by 6, so what we're really getting is negative 36r is equal to negative 30r minus 60 plus 6r. Okay. Then you move it to this side. Plus 30 is negative 6r minus 6r. Okay. Same answer. So you could also multiply by 6. But it must have been a computational mistake somewhere. Okay. So no worries. Now that I've told you how to do it, should be fine. Right. So let's look at this. This one actually follows the same principle, but this time we have variables in the denominator. Okay, so what we're going to do, the exact same thing, right? So first, of course, we're not going to multiply yet. Move the 10 to the side. Just makes your life a whole lot easier. Okay, so after I move it to that side, it's going to be negative 4, right? Then you multiply both sides by 2x plus 13. And I saw a lot of you just get to this step, okay? And that's great. So how do we solve from now on? We just do distributive property. It's not that hard, okay? From now on, it's going to be pretty easy, okay? So get negative 8x minus 52, okay? 11x is equal to negative 66x is equal to negative 6. Okay, pretty easy, right? Any answers? Actually, any questions, not any answers.
Wait, what was the answer to number 4 again?
Answer to number 4 is 5.
Just 5?
5, yeah, just 5.
Okay, I keep on doing something wrong. Ugh.
Okay. Somebody feel my pain. Pain. Face palm. Or there's so much pain in this chat. Cat person. What's a cat person? Oh, that's a cat person. Wild cat person. How come I never seen one of those in the zoo?
A cat person is basically like a person that has like the personality of a cat, but it also means if you don't know what it means, it just seems like what it means.
Cat person. They should have those at zoos. Oh well. Okay, so now let's go to review inverse operations. Not that you guys don't know it or anything, but today is a review lesson. So for those who remain unclear on the subject, let's review it for them. So the definition of inverse operations are pairs of mathematical manipulations in which one operation cancels out or undoes the action of another. Give me examples, all right? Give me examples.
Addition and subtraction.
Great. So just
Multiplication and division.
Exponents and root.
and subtraction. So give me example with numbers in addition and subtraction, like cancel out. How you do that? Like, let me give an example. 4 minus 4 equals 0, right? So positive 4 minus 4 cancels out. Addition and subtraction. So I also heard multiplication and division. Very good. Right, multiplication and division. So give me an example. 3 divided by 3. Okay.
Also, exponents and roots.
Actually, never mind. 1 times 3 divided by 3 cancels out, equals to 1. There we go. Exponents and what? Roots? Exponents and roots.
Yeah.
Okay, how about we say whole number exponents and roots. All right, because if you have like a to the 1/2, it's going to be equal to the square root of a. But we're not going to talk about that because we're not learning about roots that soon. It's going to be a lot more complicated. Okay, so if you have a, let's say 2. Okay, so square root of 2 and square is still equal to 2. Okay, they cancel each other out. So very good. These are our 3 inverse operations that we're going to be dealing with in algebra 1. So make sure to remember them. So now let's go on to linear equations. So solving linear equations. What is a linear equation? Basically, it's an equation, but with variables, since we're dealing with algebra. So we need to have variables. That's why. Okay, so what you need to do when we're solving linear equations is you need to isolate, right? The key point. Isolate variable on one side, and then you're going to isolate the numbers on the other side. All right, so if we isolate the variables on one side and isolate the numbers on the other side, then our solution, okay, solution should be like this. X is equal to A, where X is a variable. Could be anything, could be u, could be r, could be b. Okay, where x is a variable and a is a real number. Actually, let's not use a because that's kind of confusing. So x is equal to n. N is a real number. Okay, great. So let's just go on with examples now. Okay, so example 1, right? Pretty easy, right? So I'm just showing how deliberately how to solve step by step. Okay, so let's just go on with this very simple one, and then let's go on to practice problems because we don't need to spend too much time on these. Okay, so of course
Are we
inverse
still
operation.
doing review?
What?
Is this still like technically a review?
Yeah, this whole class is a review lesson, okay? Because I don't think we're ready to move on yet because the homework was not too great. Okay? The homework was not too great. So let's take another lesson to reinforce these ideas, okay? So make sure you have them down pat because for next lesson we're going to move on to word problems, okay? Going to move on to word problems, and then we're going to have to apply all sorts of these problems, okay? And of course, it's always good to know like very well how to solve these problems before you go on to the next unit. So that's why I'm reviewing, spending a whole class on this. And of course, the homework will be another 5 questions of these linear equations, but there's a twist because in this homework, I added a challenge question. Okay, this one is like the last challenge question. Okay, what was the last challenge question? Oh, it's like combining like terms or something, right? And then that was worth 10 points. So this one is also worth 10 points. So when I send out the homework in a few hours after I'm done doing it, there will be a challenge question and it will be worth more points. Okay, you're welcome to try it, but it's optional. Okay, it's optional. So if you want to do it, you can. If you don't want to do it, then oh well. But it is worth 10 more points, and it is a word problem. So it's quite challenging to kind of put these word problems into equations because the applied problems are always the hardest, right? So solving an equation, anybody can do it, right? You give the equation to me, I just solve it, find the variable. But that's not going to work, right? In real life. What's the point of solving equations in real life, right? Okay, so then you need applied problems. So let's say you're finding out like an unknown like thing. Okay, so then your unknown thing would be that variable because variable is an unknown. So then you set up an equation and then you're trying to find that variable. Okay, so that's the hardest thing, setting up the equation. Okay, but I need to stop rambling on. Let's do this equation. So what you need to do, of course, is you need to add 3 to both sides. Or what am I doing? Subtract 3 to both sides. Subtract 3 from both sides to cancel these 2 out. Okay? Then you get t is equal to negative 11. So that is a perfect demonstration of our inverse operation, subtraction and addition. Okay? So the subtraction of 3 cancels out the addition of 3, okay, or positive 3. So then let's look at multiplication and division. So when we're dividing by -2, what we need to do is we need to multiply by -2 because when we're dividing by -2 and then multiplying by -2, these two cancel out. And of course, you need to do that on both sides. Then you get 28. So then let's combine it in this third example. So what we need to do is get the 15 first to this other side by adding 15 to both sides. Okay, so 3x is equal to 45. Then you to get rid of this multiplication, you need to divide. So you're multiplying x by 3 and then dividing x by 3, then it cancels out, right? So then you get x is equal to 45 over 3 is equal to 15. So pretty easy stuff. Now let's go on to our practice problems. So make sure to implement this inverse operations. Okay, these inverse operations. All right. So we have our own rendition of word problems here. Bob has 27 eggs and eats 2. How much money does he have in his wallet? Well, it's obviously $30 because I don't know. Oh, he's broke from spending it all on eggs. It's actually a pretty reasonable dollar. Reasonable answer. Okay. Zebo says I'm in 4th grade and I didn't do my chores. How fast can my mom run? Obviously, 3 miles per hour. Because 2 miles per hour is too slow. So 3 hours per hour. Yeah. Well, I have a word problem for you guys. If Bob has 30 eggs and eats 2, how much money does he have in his wallet? Well, he'd probably be a millionaire because he doesn't have 27 eggs this time. He got 30 eggs. That means he's richer than he was before. You see anybody that buys 30 eggs? They're obviously very rich because the eggs are expensive.
You
And he
can't.
eats 2.
You can't. So like what Isabella put in the chat, you can't fit that much money in your pocket.
Whoa.
Can I see the question, please?
Have you guys thought about credit cards? You can fit $1 million in the credit card, or he won the lottery. He could have won the lottery, or Bitcoin. Oh well. Well, you can't fit Bitcoin in your pocket because it's virtual. All right, kids, shut up and let's do this problem. I probably should have shut up first, but okay. I'll give you a few moments to do this one. Shouldn't be too hard. This one is pretty easy. All right, kids, let's see what you got. Nothing. Okay, great. Come on, kids. It's not that hard. -8. Great. At least you have one answer. I probably didn't give you guys enough time, but okay. I'm just gonna wait here for answers. Oh well. Should probably put this up. Okay, I'll wait a bit more. Okay.
Got more answers.
I know. It's like 3 answers. Tell me when I get like 10 or something. All right. Let's see what we have. Oh, we have 28. But none of them are answers. Great. We have -6. Oh, we do have some answers though. All right, we have -8, -8. -6, -8. -16 actually. All right. The person who got -16, I don't even know if that's correct or not. I don't think it's correct. It's probably, you know. Oh well. Multiply everything by 10 plus t. Okay. Cancel it out. Then you get actually let's not do it there. So then you get 10 plus t on this side. Then you get 2 t plus 26. Oh my god, this t. Why would they use t? It's so okay, I should probably curve that up. Yeah. Let's make this fancy t. There we go. 26. Okay. So then what you need to do is, oh god. The -16 guy is actually correct. So what you need to do is you need to move the t to that side. You get t by itself. Oh, what is this? Yeah, get t by itself. Then get 10 minus 26 is equal to -16. Oh wow. Who got -8? What a shame. Who got a -8? Okay. Oh well. Ethan, very good job. Good job. And William, you got -16 too. Good. It's good. All right. Let's go back.
Wait, the correct answer is -16.
Yes. Let's check it. If you put -16 in here, then -16 plus 13 is -3. So 2 times -3 is -6. Okay. And then -6 over -6 is 1. So it doesn't work. So if you're ever unclear about your answers, just plug it in. If x is what it is supposed to be, x plus 1 is equal to 2. We know that x is equal to 1. How do we check it? We put it back in. If x is equal to 1, then we substitute x for 1. Then get 1 plus 1 equals 2. That's correct. If it's correct, then that's correct answer. If it's not correct, it's not the correct answer.
I
All right.
plugged it in and got 1 point something.
You plugged -16 in and got 1 point something.
No, -8.
Oh, so that's incorrect. See? So if the equation, once you plug it in, is incorrect, then your answer is obviously not correct, because if it were correct, then the equality would be true. So enough of that. Let's continue. So I'm going to move a bit fast on this one. Let's do this. Multiply by 5. Everybody multiply by 5. Z minus 24 is plus 40z, okay, is equal to 5z plus 20. All right, multiply everything by 5. Great. So then what you need to do is you need to move -24 to that side, okay? Then you get 41z, then minus 5z. What you get? 36z is equal to 44. Z is equal to 36 over 44, which is going to be something, but I don't know what that something
I
is. So
think
I'm gonna have to,
well, I think 40z minus 5z is supposed to be 35z.
what?
It's what? Wait,
I think
it's
40z minus 5z
We
is
still have this z right here.
oh,
wait. What?
we still
Because
have
you're adding this z to this 40z first, you get 41z, then minus 5z is going to be 36z, then you move this -24 to that side, it's going to be 20, then it's going to be 44, then it's 36z divided by 36 is equal to 44 divided by 36, or oh shoot, I did something wrong.
Oh my god. It's
There you go. Because it's 44 divided by 36. Yeah, I
oh
did the other way
yeah,
around.
yeah.
I did 36 over 44, which is kind of stupid. But okay. We're running out of time. Let me handle this. So what you need to do is you need to multiply this thing, distribute the 3, okay? 3a minus 2, okay? Because 3 times -2/3 is going to cancel out the 3, right? It's going to cancel out the 3, then you get -2. So then you got 3/4 a plus, we don't want mixed fractions,
9 over
9 over
4.
4. Okay, so what do you do? You need to multiply everything by 4, because we don't like fractions in algebra, because fractions suck. So so then we multiply by 4. Everything multiplied by 4. I'm going crazy. But everything multiplied by 4, we get 12a minus 8 is equal to 3a plus 9. What do you do?
We
Move
add 8.
move
uh,
9a is equal to 17a. It's equal to 17 over 9.
Wait.
So I made
Wait,
a mistake.
what?
I think I made a mistake. But
Wait.
I
How'd you
think
get 9a?
how did I get 9a? 12a minus 3a. It's 9a.
Why did you subtract what? Like,
Okay. I have to stop being fast. Okay. So 12a minus 8 is equal to 3a minus 3a plus 9. Then you minus 3a from the side too. Right?
oh,
Okay. Then you get 9a, because you move the -8 to the other side too, right? You get 17. So 9a is equal to 17. Then a is equal to 17 over 9. You divide by 9, right? Did I make a mistake? I think I made a mistake, but I don't know. I don't think I made a mistake. Okay, let's move on. So what you need to do here is, what are we going to do here? Oh, well, first of all, this is equal to 2 plus a over 4. So then you get this. You get two different denominators. So what are we going to do? Remember
oh,
that
it's
trick?
the same as dividing it by the whole number.
What whole number?
Like multiplying by 1/4 is just the same as dividing by 4.
That's true. That is true. And then what do you multiply? Least common multiple. Least common multiple. So what is the least common
12.
multiple? Great. 12. So everybody multiply by 12. You get 4, 3a plus 8 is equal to 3, 2 plus a. Okay, so 12a plus 32 is equal to 6 plus 3a. Oh, 9a is equal to negative 26. A is equal to negative 26 over 9. Great. We're done here. Did I do something wrong? I think I did. So if you multiply by 12, okay, so if you multiply 3a plus 8 over 3 by 12, then the 12 and the 3 cancel out. So you get 4 times 3a plus 8. And then you get 3 times 2 plus a. So then you distribute the 4. You get 12a plus 32. And then 6 plus 3a. Actually, there's no use doing this. Why don't we just plug it in? Let's just plug it in. Just plug it in. Plug it in to, actually, let's not plug it in because that'd be pretty sad. So many fractions. But I think I did correct. Right. The chat is exploding again. Great. All right. Practice problems. Number 5. Again, we do have this distributive property thing. So what you need to do, distribute the negative 3. Remember, negative 3 times negative 7 is equal to plus 21. So negative 3h plus 21 minus, actually minus, yes. Minus 24h plus 12 is equal to 6h. Right? Then you simplify. So 33 minus what? Minus 27h is equal to 6h. 33 is equal to 33h. So h is equal to 1. Right? Am I correct? I think I'm correct. Okay, any questions? Any questions on this one?
I think everyone's just typing. We don't talk about Bruno lyrics into the chat,
I'm not.
Great.
except for Zebo.
Rats along his back. When he calls her name, it all fades to black. Okay. So that's our last practice problem. Thank you for listening, everybody. Okay, I'm done here. Save this. Stop recording. Great. So thank you,
Bye.
everybody, for coming. Yes, great. Yeah. To stop with all the formalities, let's just